Assalamualaikum warahmatullahi wabarakatuh. My name is Melani Putri. My number ID is 2110118120012. Today I will explain about material of 14 meeting. For the first is vocabulary, is cube. A cube is a solid shape with 6 square faces. Each square face has the same side length and thus all the faces have the same size. A cube has 20, a cube has 12 edges and 8 vertices. Each vertex refers to a corner where 3 edges of a cube meet. Number 2, cuboid. In geometry, a cuboid is a solid shape or a three-dimensional shape. A convex polyhedron that is bounded by 6 rectangular faces with 8 vertices and 12 edges is called a cuboid. A cuboid is also called a rectangular prism. A cuboid with 6 square faces is called a cube. Number 3, pyramid. A pyramid is a structure whose outer surface are triangular convert to a single step at the top, making the shape roughly a pyramid in geometric sense. The base of a pyramid can be trilateral, quadrilateral, or of any polygon shape. As such, a pyramid has at least three outer triangular surfaces. Next, number 4 is prism. In geometry, a prism is a polyhedron confessing an unsided polygon base. A second base, which is a translate copy, or rigidly move without rotation of the first and other face. Necessarily are parallelograms joining corresponding sides of the two bases. Number 5, cylinder. A cylinder is a three-dimensional shape consisting of two parallel circular bases joined by a surface. The center of the circular base overlaps each other to form a right cylinder. Next, number 6. Sphere. A sphere is a geometrical object that is a three-dimensional analog to a two-dimensional circle. A sphere is the set of points that are all the same distance or from a given point in three-dimensional space. That given point is the center of the sphere and R is the sphere's radius. Number 7 is cone. A cone is a three-dimensional geometric shape that tapers smoothly from a flat base to a point called the apex or vertex. A cone is formed by a set of line segments. Half lines are lines connecting a common point, the apex, to all of the points on a base that is in a plane that does not contain the apex. Next, number 8 is edge. In geometry, an edge is a particular type of line segment joining two vertices in a polyhedron, or higher dimensional polytope. In a polygon, An edge is a line segment on the boundary and is often called a polygon site. Then, number 9 is surface area. The surface area formula is a mathematical solution to find the total area of any three-dimensional object occupied by all of its surface. Let us understand in detail about surface area formulas of different 3D shapes. And the last, number 10, is vertex. In geometry, a vertex is a point where two or more curves, lines of edge meet. As a consequence of this definition, the point where two lines meet to form an angle, and the corners of polygons and polyhedra are vertices. Next, I will explain about the video. With the theme is combination formula, probability, and combinatorics. The video, we have 6 people, person A, B, C, D, E, and F. If we put them into 4 chairs, how many permutations are there of putting these 6 people into 4 chairs? The solution: there are 4 chairs and 6 people. So 6 times 5 times 4 and times 3 equals 360. The permutation formula is 6 times 5 times 4 and times 3 equals equals 6 times 5 times 4 times 3 times 2 and times 1 over 2 times 1. So we have a permutation formula is 6 factorial over open bracket 6 minus 4 close bracket factorial. So we got the permutation formula is the number of R such a permutation of n equals n factorial over n minus r factorial. The permutation of 6 people into 4 chairs is the number of 4 such permutation 6 equals 6 factorial over 6 minus 4 factorial equals 6 times 5 times 4 times 3 and times 2 factorial over 2 factorial. So we have 6 times 5 times 4 and times 3 equals 360. So the permutation of 6 people into 4 chairs are 360. Next, still in the video, we have 6 people, person A, B, C, D, E, F. If we put them into 4 chairs, how many permutations are there of putting these 6 people into 4 chairs? Solution: there are 4 chairs and 6 people. So 6 times 5 times 4 and times 3 equals 360. So we know A, B, C, D and C, A, B, C. In combination, this is the same. So the combination formula is the number of ways are arranged K thing in K squared is like that. From the permutation formula we got we got n choose r equals the number of r such a number of n over r factorial equals n factorial over n minus r factorial over r factorial equals n factorial over r factorial times n minus r factorial. If we didn't care about who's sitting in which chairs, we could use the combination formula. 4 choose 6 equals 6 factorial over 4 factorial times 2, 6 minus 4 factorial. So, times 4, 6 times 5 times 4 factorial over 4 factorial times 2 factorial. So, we have a 6 times 5 over 2 times 1 equals 30 minus 30 over 2. So, we have a combination is 15. So, the combination of 6 people into 4 chairs are 15 ways. Then for video, I will next to explain about example. The first example is example 7 with the question, student ID numbers all have a characters. The first 2 characters are different letters chosen from the letter A through F. The remaining 6 characters are digits from 1 to 9 which can be prepared. How many different ID numbers are possible to create? Solution. From the question, we know that for the first student ID number have a characters. The first and the second are different letters, choosing A through F equals 6 letters, and the 6 characters remaining are digits from 1 to 9 equals 9 number. So, in this situation, it's the same as filling a slots because student ID numbers all have a characters. Then 6, 5, 9, 9, 9, 9, 9, and 9. So 6 times 5 times 9 times 9 times 9 times 9 times 9 and times 9. And we know that the same with 6 times 5 times 9 to the power of 6. So we have the value is 15,943,230. So there are 15,943,230 possible ways to create different ID numbers. Next is example 8 with the question, how many ways can 4 out 7 students be seated in a row of 4 chairs? How many ways can all 7 be seated in a row of 7 chairs? With the solution, we can use a permutation formula to solve the problem. So the number of R, the permutation of n equals n permutation n factorial over n minus r factorial. For the first situation, 4 out 7 students be seated in a row of 4 chairs. In this question, we have two situations. For the first situation, 4 out 7 students be seated in a row of 4 chairs. So, the number of 4 such 7. The number of 4 such permutation of 7 equals 7 factorial over 7 minus 4 factorial equals 7 times 6 times 5 times 4 and times 3 factorial over 3 factorial. So we know the value is 840 ways. For the second situation, all 7 be seated in a row of 7 chairs. And the number of 7 such a permutation of 7 equals 7 factorial over 7 minus 7 factorial. So, 7 factorial over 0 factorial. We know that if 0 factorial is equals 1, so 7 times 6 times 4 times, 7 times 6, 7 times 6 times 5 times 4 times 3 times 2 and times 1 over 1 equals 5,040 ways. So there are 740 feasible ways can 4 of 7 students be seated in a row of 4 chairs, and 5,040 possible ways can all 7 be seated in a row of 7 chairs. Next, example 9. With the question, Mr. Fredericks wants to have a mock election in his social students class. Students have to elect 4 people to serve as class officer. If 9 students were nominated, how many possible different groups of 4 could the class elect? Solution: we can use the combination formula to solve the problem. So, combination n choose r equals n factorial over r factorial times n minus r factorial. So, combination of 9 choose 4 equals 9 factorial over 4 factorial times 9 minus 4 factorial. So, we have a 9 factorial over 4 factorial times 2 5 factorial. So, 9 times 8 times 7 times 6 times 5 factorial over 4 factorial times 4 times 3 times 2 times 1 factorial times 5 factorial. So, we have a delete 5 factorial because menghasilkan 1 equals 9 times 8 times 7 times 6 equals 4 times 3 times 2, and the value from combination in this question is 126. So, 126 possible different groups of 4 could the class elect if 9 students were nominated. In the last example is example 10. With the question, how many different diagonals can be drawn in a regular octagon or an 8-sided figure with equal side? Solution. From the problem, we can label the vertices A through H, and the connection between 2 vertices will form a diagonal. So, we will find the number of combination. So, the combination of 8 choose 2 equals 8 factorial over 2 factorial times 8 minus 2 factorial. So, 8 factorial over 2 factorial times 6 factorial equals 8 times 7 times 6 factorial over 2 times 1 factorial times 6 factorial. So, we have a delete 6 factorial because menghasilkan 1. So, 8 times 7 over 2 times 1 equals 28. 8 of these pairs are not diagonals, but side of the octagon is 8 of these pairs are not diagonals, but side of the octagon. AB, BC, CD, DE, EF, FG, GH, HA. So the total diagonal of the octagon is 28 minus 8 equals 20. So 20 different diagonals can be drawn in a regular octagon or an egg-sized figure with equal sides. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.